Thank you, everyone, for joining us here tonight. Whether you're joining us online, live, or recorded, we are so grateful that you're spending some time with us. My name is Pierce Paul Kriesman, and it's my pleasure to serve as the Executive Director of ACOR. And tonight we have a wonderful lecture. Now, we have Professor Sahar Al-Khasawneh, and I try so hard to get the accents right, who is an associate professor in the Department of Conservation and Management of Cultural Resources at Yarmouk University. And I want you to know that when I was doing my research to give this wonderful introduction, I got to the third line of the research and it said, nuclear physics. And I stopped. So the good professor is in fact engaged in nuclear physics research and a number of other fields that all relate back to the archaeological sciences. So we are so very fortunate to have with us tonight her here for this lecture. If you have the ability to join us, we have one more surprise lecture in our series this semester on June 11th at 6:30. We will have a Czech professor, and the Czech Republic Embassy in Amman is sponsoring a lecture here about the pyramids in Egypt at Abu Sir. So we're very fortunate to have that collaboration coming on June 11th. We hope we can receive you then. But until then, come on up. Thank you so much for joining us tonight.
Okay. Thank you, everyone, and thanks, Pierce Paul. Actually, talking at ACOR was always an ambition, and now it is happening. Thank you for inviting me here. My talk, as you see, it is about the desert kites, but mostly it's about dating and timing the desert kites. So first, I will give a small introduction about the desert kites. The desert kites are large ancient stone structures that cannot be seen from the ground level or from the surface because they spread for a long distance. They can only be seen from the aerial photographs or from the satellite images. There is around 6,000 of these structures that are spread all over the Jordan region, Saudi Arabia, Yemen, Negev, and some of them even in Central Asia. However, the majority of them exist actually in the Eastern Jordan, in the Harat Sham area. That's where the majority of the kites and other megalithic stone structures also exist there. The stone structures, or the kite, structures, they take their name from their resemblance to a kite, a child toy, where there is a long, low stone walls that have a funnel shape. This funnel shape ends up in an enclosure, like a star-shaped enclosure. And at the end of this enclosure or the corners, there exist some small compartments or cells in a 3 to 5 meter wide. Those small cells are called the hides and the blinds, where the long walls are called the guiding walls. And these names comes from the function of the kite, which we will talk about it in a few seconds. The first to notice these kite structures and to give them the name is the group captain Lionel Rees, a British from the Royal Air Force in British, who was flying between Amman and Baghdad and Cairo and Baghdad in the early of the last century, around 1920s, when he noticed these structures in the basaltic desert of Eastern Jordan. Rees did not only describe the kite structures, but he also suggested a function of this kite structure and also suggested that these kites might have been reused or rebuilt in many times or in several periods of the past. This image is actually published in Antiquities in 1929 by an article published by Rees, and this represents the first aerial images of the kite structures in Eastern Jordan. But nowadays, with several aerial images taken from helicopters flying or satellite images, Google Earth, archaeologists have the ability to identify several types of these kite structures that not are exact resemblance to a kite shape. This mostly is spread actually in Saudi Arabia, Negev and Sinai, and part of them in Yemen. but most of the scholars still call them the kite structures. In Jordan, and especially in eastern Jordan, where there's many of the engraved rocks, they found several rock arts that describe or have engraved of the kite diagrams on it. And these diagrams is like a schematic sketch or engraved for the planning the kite, drawing the kite. And some of them actually have also this explaining the function of the kite. Rees, in fact, in his publication in 1929 in Antiquity Journal, he described the function of the kite as being used for herding sheep and keeping sheep in their place. But in the same article, the editor noted that we should read Beckhart's work, that he talks about hunting games for gazelle animals in the desert of Syria. He called that these hunting games were chasing animals into closed walls, also built from stone in the level of the surface, in the level of the ground. And they called them masyada. Masyada is the Arabic word for a trap. And this hypothesis of using the kite structures for hunting animals became more accepted by archaeologists and scholars. That's not only by survey analysis and excavations, but also by the artwork. The artwork in the rock engraved shows some kind of hunters chasing the animal into the guiding walls, and that's where the name of the guiding walls came. They were chasing the gazelle especially into the enclosure. And in the enclosure where the cells and the blinds exist, some of these cells, the animal will fill there and the hunters would be waiting for them to catch them or to capture them. This function became acceptable for some scholars, especially also that there was similar of these hunting traps that exist also around the world, not only restricted to our region in Jordan and Saudi Arabia. Some of these were described since 1929 in the North America, where they described a stone wall structures, also with a rock art that's showing hunters chasing their prey into small compartments, similar to the cells and the blinds that exist in the kite structures. Another hunter will be waiting here, waiting for the prey to reach or arrive and capturing it later. Similar to these structures also exist in Central Asia, like in Kazakhstan and Uzbekistan, where we can see from satellite images, these structures are resemblance to the kite structures in Jordan. In Jordan, within the last 100 years, there was an extensive work by many of the archaeologists and the scholars who worked in Jordan, and they have a significant contributions about these kite structures. This work was done by ground survey, by aerial images, by also the modern techniques, the drones techniques, and they have a good or like important contributions about the kites, their functions. But there was always a question, when those kites were constructed, when they were built. Have they been built all in the same times, or have they been built in several periods or different periods? Are they still in function or not? But unfortunately, trying to date the kites was always difficult for the scholars, because there's a scarce and a little amount of organic materials that can be found in these sites. And the organic materials is always used by C14. So there was always a scarce and a problematic in how to date the kites and to have a direct related time of construction for the kites. So usually it seems like that this is a hunting trap, but the capturing of the animal was happening in the kite structures. However, the slaughtering of the animal was done in another place. And that's why there's a scarce of the organic material or bones that can be used for dating. So scholars and archaeologists used a proxy way of dating. In another world, they were collecting materials or artifacts that is surrounded and fell in the vicinity of the kite structures or related to a site located near the kite structures, and use that date to say or to talk about the time of the kite constructions. But now, with the new developments of absolute dating in archaeology, there's another way that we can use for dating the kites. and that's by luminescence dating. Luminescence dating is used the mineral quartz that exists in sand to date the time of construction or the time of exposure to light or firing. And of course, sand is the most abundant material that exists in these kind of structures because they are either filling the blinds or the cells in the kite constructions, they are either into the rocks that is forming these kite structures, or they are just deposited within the rocks that forming the walls or the cells or the enclosure of the kite. So with this development, we can now use the OSL for understanding when these kite structures were used. And that's actually my specialization. I'm not an archaeologist, as Paul said, I am actually a physicist. So that's my specialization. And to give you an idea how OSL is done or what is the principle of OSL, I will make a short introduction about that. Luminescence dating is based on the principle of the ability of a mineral like quartz to store energy inside it. That energy can last for or be stored for a finite or a limit of the ability of a quartz to store the energy. It's like a battery. Like a battery, we have a finite capacity for storing the energy. And the energy being stored by exposing to several kinds of radiation from around the quartz mineral, like the radioactivity that exists in thorium, uranium, or potassium in the sand. However, if this quartz grain is exposed to light or exposed to heat, for example, by transporting the sediment by wind or by water, or it's exposed to heat by manufacturing like pottery materials, then the energy of this battery will be reset to zero, or as we say, it's a bleaching process. And this bleaching process releases the energy that was stored into a shape of a light. And that's where luminescence word came for it, the luminescence dating. Again, when this mineral is covered from light or covered from heat, then we will see it starts again to reaccumulate energy and to start to store this energy inside this mineral. And now that's our target usually. When was the mineral was last exposed to light or was exposed to heat? And knowing when it was last exposed to light, we can quantify that in the laboratory by measuring how much energy is stored in the quartz mineral and how much this energy or was receiving energy during that time. And that's how we calculate the luminescence age for a quartz mineral. The technique has developed in the future, in the recent years, and this developed is not only for the loose grains from quartz in the sand, but the technique was developed for rocks. And rocks is a solid material that is thick and that allow for light to penetrate into it, but it penetrates into a gradual decay into the rock. So the rock surface dating, the technique as is known, is now measuring the luminescence as a function of depth. And knowing this function of depth allow us to know how long this rock has been exposed to light. To illustrate that in a schematic diagram, imagine if we drill a core from a rock. This rock has never been exposed to light, so light never penetrated in it. And we try to measure the amount of energy stored as a function of depth. We'll see it is in full saturation. But if it was exposed to light and then trying to drill the same core and measure it, maybe after 1 hour, we can see the amount of energy start to decrease or going down, being released. And that's due to the penetration of light into the rock. But light penetration into rock is very slow. It doesn't happen very fast. So 1 hour was barely to reduce the first surface up to 20% of its maximum amount of energy. 1 day is enough to reduce the first millimeter up to 0, but it still have something inside and still in saturation into the middle. Keep exposing the rock to the light for hundreds and thousands of years, we will have a different degree of releasing energy deep into the rock. This allows us to actually quantify how long it was exposed based on how deep the energy is released into the rock. But what if the rock was again covered from the light? Would it still be releasing energy, or it would start rebuilding and restoring the energy? This gives us an idea to look into the history of the rock by the history of exposure and burial events. For example, the same rock that has never seen light, it is in fully state. That means it has an energy fully saturated. It was exposed to light. This happened maybe as natural event, or happened as using the rock for construction building or pavement or road or something. So we see here that it lost the energy up to deep 15 millimeter after a long time of exposure. We still see history of its previous storage of energy and the full energy level of the rock. But if it was buried again, for example, being buried by sediment or being reused or flipped around, for some reason, the rock is no longer seeing the light, no longer exposed to light. Then the energy is not released. It is in the opposite. The rock will start building and storing energy. So we will see the level of the energy increase in the first millimeters or the early surface of the rock. But with that, it is still recording its history of exposure at the depth here. Another event, another exposure. So again, that energy level at the surface will release, because that's the light where it penetrates faster and earlier. And also we have a history or a record of a previous burial and a record of the earlier even exposure. This kind of profiles, we can have it as long as we have a sequence of burial exposure events. And these profiles are expressed as a mathematical modeling for the amount of energy that we measure and quantify in the laboratory. And that's how we do it actually in the laboratory. It is a little bit hard work, but it always gives a nice results. We just pick up a rock from an archaeological site or related to a geological events that we know that this is related to the event we are targeting, like construction or building, or for example, geological events like an earthquake or others. We drill the cores, cutting it into slices, each slice of 1 millimeter thickness, and then trying to measure it using the luminescence reader that can measure the amount of energy into each slice. So now with this technique, you know it, we use them to timing or to identify the time of kite constructions. The first example is about a rock that we took from one of the cells or the blinds that were forming a kite structure. The rock was used in building the wall in this form. So we drilled from surface A up to surface B. And we measured the energy at each of these millimeter into the core. We had a very nice profile that can tell us the history of light exposure and burial for both sides. Not only the side that is exposed in the wall construction, but also for the side that was touching the pit or the ground. So how is this profile tell us the history of this rock and how we know the age from this profile? I will follow with you step by step the history of the rock as we did by mathematical modeling. Obviously, the rock was first completely buried, or it is in geological state. That means it has a full capacity of energy. But at one time in the past, surface B has been exposed to light. This exposure to light could be by natural causes, not by human or using it in construction. And that allows for surface B to completely lose its energy, to go down to the zero, as you see in the blue line. Later on, the rock was used in building the kite. It was exposing surface A to light, but hiding surface B. So surface B is no longer losing the energy. In the contrary, it starts to build the energy. While surface A has lost the energy and went back down to zero, the amount of energy. That was during or exactly after using the rock in building the kite, and during also using the kite. Then the kite was abandoned and no longer in use. And the cell that has this wall has filled with deposits. So no longer the both surface A or B can see the light, and there's no more of losing or releasing the energy. So both surfaces started to build up the energy. Surface B continued building up the energy, so it raised up the level of the energy stored. And surface A also built up the energy. After excavation and before collecting the rock for samples for about 6 months, surface A was exposed again to light. So we see drop in the first 2 millimeters of energy down. Now here we can see that this is a burial age. That means when it was buried and the kite was stopped of using into hunting. And this is the time of construction. Both should be around the same age, and that's what we have in 1 sigma of error. This kite was constructed around 9,000 years ago. That is during Neolithic time. So this was a very successful publication in 2019. We tried to take this attempt and doing into the Harit al-Sham kites. The Harit al-Sham, the eastern part of Jordan, where the majority of the kites exist. However, this was not quite successful application because Harit al-Sham rocks are basalt, and basalt have a low content of quartz. And the bigger problem actually is that the basalt is so dark, it doesn't absorb light. It doesn't allow light to go inside and affect the quartz grains in the rocks. So rock surface was not successful in this case. But we were lucky actually for having a publication about it to give the scientists and archaeologists what to expect from different kinds of rocks when they are trying to apply the rock surface dating. Because you have basalt, you have sandstone, you have limestone, you have granite, you have marble. So with these different lithologies of rocks, rock surface act and behave differently. So this publication was quite good after the failing attempt of dating the kite, but we still need to date the kite. And that's when we use the conventional luminescence dating for the loose grains of sediments and depositions into the kite structures. Our study was applied to a kite excavated by the project Kites in Context, led by York Rowan and Chad Hill. They uncovered 3 cells in one of the kite's constructions. These cells showed a line of basalt stones, and there was sediment and depositions in these cells. So here we collected different of the sediment and depositions that targeting 3 events. One event we were trying to target is before the kite construction, before the kite was built and used. The other event we were trying to date is timing of the kite constructions and later depositions that happened after, caused by abandoning the kite or stop working or by natural water movement and carrying the sediment with it. When we did that, I was a little bit afraid that also because there's low content in basalt, that also the depositions in these kites will have also low content of quartz, sorry, not basalt, low content of quartz. But for my surprise, it has a good amount of quartz, and moreover, it has a good amount of feldspars. Feldspars is also used by luminescence dating. So for each sample, we could have actually 2 ages, one for quartz and one for feldspars. And that allows us to see the reliability of the luminescence dating for sediments by comparing the ages from quartz with the ages from feldspars. If they match at least with 1 sigma of error, that means that both mineral has been exposed to light enough to fully reset the energy and to start accumulating the energy after the kite was constructed. And this agreement happened for most of our samples, the ones that we were targeting the event before kite building, during kite building, and after. And for the samples we were targeting the kite constructions, we see that the ages are around 8,000 kilo years. That is like late Neolithic time. That's another absolute and direct dating for kite constructions. So to wrap up, and I hope I'm not too late for you, to wrap up, luminescence dating is one of the suitable and appropriate dating techniques for the stone structures like kite and another megalithic structures, and there is now successful applications about that. The earliest timing of the kite structures goes back to Neolithic and up to late Neolithic times. This actually ages has been suggested before by survey working and by indirect dating by many scholars, such as Alison Betts' works, for example. And hopefully, in the future, we will do more of luminescence dating and more of these applications in our lab at Yarmouk University. We have now started our own OSL labs, and we are running it for both rocks and sediments. And thank you very much.
Thank you so very much. I am going to take advantage of having the microphone and ask two questions.
Okay.
One, have these studies been done against the different styles of kites, the different designs? So the ones in Jordan look more kite-like and the ones farther south?
The luminescence dating,
Yeah.
no, it's been selected now for the two kite structure. But there is a study, and I think it's published in 2015 with Gary Ruppelson, that they dated a circular megalithic structure that is located in the eastern. So it is another form of megalithic structures, but not a kite.
If only we had Gary in the audience right
He
now
is
to
here.
tell us. I know.
But the rock surface, it was applied to different types of megalithic structures. The linear Khatshabib, for example, linear structure in southern Jordan, to the big circles structures. They are not hunting traps games, maybe. They are not like a kite, but they are also stone structures that they lack for organic material for dating. And luminescence, especially rock surface, was the best technique to be applied there.
Wonderful. And the second advantage I will take is how narrow a window is the dating? So if the construction, abandonment, and construction and abandonment happened within 1 year,
We could see that.
you could.
Yeah, you could see that. Especially, it depends on the type of the rock. The more it is rich with the quartz, the more you see the profile very clear and it's losing the energy. But you can see within years the difference in the profile.
That's amazing. Okay. I don't know, Gary, can you ask a question? It feels like cheating.
Sahar, thank you very much. In the Harat Assam, there are these very long chains of kites, maybe, I don't know, 40 kilometers long or more. And so that represents 40 different, probably, construction periods.
Yes.
It may be 40 years, or it might be 350 years. Could you tell at the lower part of the chain if it's older than the upper part of the chain?
Yes, yeah. Like this, for example, you can see that the guiding walls are actually overlapping, which might suggest that the kites were rebuilding or was building over it and reusing the guiding walls. It is possible, but this would be always with the help of an archaeologist. If you have an idea that this might be the part where the building started, and this is where the part it was reused, then you can identify that by collecting the samples from sediment or from rocks. If it's not basalt rocks, of course, then you can see the difference on the ages. The time, the uncertainty in luminescence dating is about 5%. That's if we have a good measurements and enough amount of grains to remeasure and have a large number of aliquots measures, which give us a good statistical to reduce the uncertainty. So 5%, it could cover this period.
Thank you.
Dr. Sahar, thank you so much for a very informative lecture, very interesting one. I wanted to ask you, can you describe us the hunting procedure? And I mean, did they do it like walking, or were they on horses? And what animals did they hunt? You said gazelles were, some of them. If you can elaborate on that, we would be thankful.
This would
Thank
be
you.
better for archaeologists to do, but I'll try my best as far as I understand the process. So this is what happens, that usually that hunters will be chasing the gazelle, for example, between these two walls. The gazelle, in its perception that behind these walls, he cannot run or jump, because it just by default, he would follow the walls and keep pushing them into the gate or the entrance of the enclosure. In these corners where they were dug as a pit or like a cells, if the gazelle fell, he cannot jump back because it is higher, or the hunters would be waiting in these corners to capture the gazelle. This also, as we said, has been noticed in North America in similar structures like that, and as described since 1980s, 20s, that also in Syria, they call it the masyada, and masyada is the trap.
Thank you very much for a very interesting lecture. As an archaeologist, I'm always concerned about relying on one particular way of doing chronometric dating. And we have big problems in my country, in the UK, when we're using OSL dating, for example. So the question I'm asking you is that with all the research that's been done on kites, has there been an attempt to mimic the dating through, say, paleosols, which may be underlying the wall structures of these kites, and whereby you can correlate the two dating methods together to get a Bayesian date, for example?
That's what we are now working on. It is under publication for the heritage sham kite. We compare the quartz ages to feldspar ages, because there's no C14 ages that we can rely on or other techniques that has been applied. So we use luminescence dating itself, but for two different minerals, feldspars and the quartz. And we also take random samples that is not related to the quartz, but we know it is like has a geological movement or a formation in that. So we see if the ages are suitable with the formation of the site or not.
Thank you again, Dr. Sahar. I want to ask about, you said there's light and energy. Is there the way that you can differentiate between the light or the energy that comes within like the core or something underground or something, or like an asteroid that hit the area?
Yes,
Thank you.
Well, we use energy for simply to illustrate the meaning, but what really happens in a quartz mineral, which has a crystalline structure, is that it has some defects, and these defects is related to the level of electrons movement in this level, in this crystalline structures. So when the electron basically move from one level to another level, it releases light, and that light is the luminescence. It releases it in the form of photons, and photons is represented in solid material as energy. That's why for describing or talking about the principle of luminescence, we talk about energy rather than to talk about electrons and the charging movement into the crystalline structure. But the radiation or the exposure to light will release that energy as a form of light, which is called luminescence.
Thank you, Dr. Sahar, for this interesting lecture. My question is that you talked more about the stones that you can date. How about the sediment? I was thinking actually about the sites that are exposed to the light for a while. Then, for example, if you are working in a season in one of the sites, it was exposed for like 2 or 3 months. Then we cover it back, and then we come back to the site, and we ask you to, for example, to make a date-to-date. Is this light that happened like 2 or 3 years ago on the same sediments, does it affect the way that you do your dating?
So when we collect luminescent OSL samples for sediment, we do not collect any sediments that has been exposed to light during the excavation. So you will take a section, like in the case, go again down. Like in this case, as you can see, we have the tubes here, those to collect the sediments that has not been exposed during excavation. And we do not avoid even the surface or the layer that is already exposed, and just take deep into the layers. And for the rocks, like the case I presented, it was exposed after excavation for 6 months. But we traced that change into the rock. And we knew that the drop of this energy was because of the excavation time. So it's rock, you can trace it and you can see it. In sediment, when it is exposed to light, you lose the energy or you lose the signal, and that's no useful for it. That's why we always target the deeper layers that has not been exposed during excavation.
Thank you very much for this very, very interesting lecture. My question is about sensitivity of light for the stones. Are you able to differentiate different types of light exposure, say underwater, under plaster, in an interior space versus an exterior space?
Yes. For the rocks, as we said, it turned out it behaved differently from one rock to another rock based on the content. Because some rocks, we noticed that despite it is rich with aquatic grain, but it somehow is coated with another material like calcites that's used as a adherent material into the rock. But what we do is we take the rock, we drill the core, and we do measurements, and then repeat the process that happened in the nature by giving irradiation to the rock itself. And then again start measuring it. So you have a laboratory calibration for every rock by itself. And you can then identify the light behavior based on that.